Welcome, gentle listener, to another peaceful journey through the cosmos with Sleepy Science Channel. Tonight, as you settle into the comfort of your bed, allow yourself to drift away on a voyage through our solar system, a place of wonder, beauty, and infinite tranquility. Perhaps you've had a long day, filled with the rush and noise of earthly concerns. Let all of that fade away. Now, like distant stars disappearing into dawn. Tonight, you are an explorer of the infinite, floating weightlessly through the vast, silent expanse of space, where time moves differently and peace is found in the gentle dance of planets around our sun. We'll discover together 100 fascinating facts about our cosmic neighborhood, each one a soft stepping stone carrying you deeper into restful sleep. From the warm glow of our sun to the icy reaches beyond Neptune, we'll explore worlds of impossible beauty, where diamond rain falls through methane. Skies and ancient storms larger than our entire planet spin in serene, eternal motion. As we begin this journey, take a deep breath and feel your body sinking into your mattress, becoming as weightless as an astronaut drifting through the cosmos. Let your mind expand to encompass the vastness around us, where distances are measured not in miles but in the gentle passage of light itself, taking minutes and hours to travel between worlds. If you enjoy these peaceful explorations of science and space, consider subscribing to our channel for more restful journeys through the universe. But for now, simply close your eyes and let the wonders of our solar system carry you into the most peaceful sleep. Let us begin our cosmic voyage, starting with the heart of our system, the Sun itself. Chapter 1. The Sun, our gentle star. At the center of our solar system burns a star so vast that over 1 million Earths could fit inside it, yet it appears to us as nothing more than a gentle circle of warmth in the sky. Our Sun formed 4.6 billion years ago from a collapsing cloud of gas and dust, condensing slowly over millions of years until its core became hot enough to ignite nuclear fusion. Even now, as you rest, this ancient process continues in perfect harmony, converting 4 million tons of matter into pure energy every single second, sending warmth across the impossible distances of space to touch your face on summer afternoons. The light now filtering through your window began its journey at the Sun's core, where temperatures reach 27 million degrees Fahrenheit. It takes light approximately 100,000 years to travel from the Sun's core to its surface, bouncing randomly through the dense stellar material like a gentle pinball. Once it reaches the surface, this same photon races through the vacuum of space at 186,000 miles per second, covering the 93 million miles to Earth in just 8 minutes and 20 seconds. The sunlight warming your childhood memories was created deep in stellar fire when your great-grandparents were young. The Sun rotates on its axis once every 25 days at its equator, but takes 35 days to complete a rotation at its poles. This differential rotation creates the complex magnetic field lines that dance above the Sun's surface in graceful, sweeping arcs. Sometimes these magnetic fields become tangled and snap, releasing bursts of energy called solar flares, cosmic fireworks that paint auroras across Earth's polar skies in curtains of green and gold. Even now, the Sun breathes out a constant stream of charged particles called the solar wind. This solar wind travels at speeds of up to 1.8 million miles per hour, creating a vast bubble around our entire solar system called the heliosphere. Like a cosmic embrace, this bubble protects us from most harmful cosmic radiation, extending far beyond the orbit of Pluto into the interstellar void. The Sun's surface temperature is approximately 10,000 degrees Fahrenheit, but its corona, the wispy atmosphere visible during eclipses, reaches temperatures of over 2 million degrees. Scientists still puzzle over why the corona is so much hotter than the surface below it, making our nearest star a mystery that continues to unfold even as it faithfully provides the energy that drives every breath of wind, every drop of rain, and every growing thing on our planet. Long ago, ancient civilizations tracked the sun's apparent movement across the sky, noticing that its path changed with the seasons. The sun appears to move through 12 constellations during the year, creating the zodiac that has fascinated humans for millennia. But of course, it is we who are moving, carried on our beautiful blue world in an elegant elliptical dance around our star, sometimes closer, sometimes farther, creating the gentle rhythm of seasons that marks the passage of our years. Sunspots, those dark patches on the sun's surface, follow an 11-year cycle, appearing and disappearing in regular patterns. During solar maximum, when sunspot activity peaks, the sun becomes more active, sending stronger solar winds and more frequent flares toward Earth. During solar minimum, our star enters a quieter phase, its face becoming almost perfectly smooth and unblemished, like a calm ocean. Under starlight, the sun's energy output remains remarkably constant, varying by less than 0.1% over years and decades. This stability has allowed life on Earth to flourish for billions of years, providing the steady warmth needed for liquid water to exist on our planet's surface. As you drift toward sleep, consider this. The same star that warmed the faces of ancient humans gathering around fires is the same star that will rise tomorrow morning, continuing its faithful watch over our small, precious world. In about 5 billion years, the sun will begin to run out of hydrogen fuel in its core, gradually expanding into a red giant star. But this transformation will be so gradual, so gentle, that it spans timescales beyond human comprehension. For now and for countless generations to come, our sun will continue its steady fusion dance, turning mass into energy, energy into light, light into the warmth that makes life possible. On our blue oasis in the cosmic dark. Chapter 2. Mercury, the Swift Wanderer. Mercury completes an orbit around the Sun in just 88 Earth days, making it the fastest planet in our solar system. Named after the Roman messenger god for its swift movement across our sky, Mercury races through space at an average speed of 29 miles per second, tracing a path closer to the Sun than any other planet. As you lie still in the darkness, this small world is completing another lap in its endless cosmic race, a journey it has repeated billions of times since the solar system's birth. The closest planet to our Sun experiences the most extreme temperature variations of any world in our solar system. During its long day, Mercury's surface reaches temperatures of up to 800 degrees Fahrenheit, hot enough to melt lead. But without an atmosphere to trap heat, this small world cannot hold on to the sun's warmth. During its equally long night, temperatures plummet to minus 300 degrees Fahrenheit, colder than the frozen methane lakes on distant Titan. One day on Mercury lasts 176 Earth days, meaning that Mercury's day is twice as long as its year. This unusual relationship exists because Mercury rotates very slowly on its axis while orbiting quickly around the Sun. If you could stand on Mercury's surface, you would witness the Sun rising, moving partway across the sky, then stopping, reversing direction, stopping again, and finally continuing on to set, all over the course of 3 Mercury years. Long ago, Mercury was likely much larger than it appears today. Scientists believe that a massive collision early in the solar system's history stripped away most of Mercury's rocky mantle, leaving behind a planet that is mostly iron core. This iron heart makes up about 75% of the planet's radius, giving Mercury the second highest density of any planet in our solar system, exceeded only by Earth. Despite being the closest planet to the Sun, Mercury harbors surprising secrets in its polar regions. Water. Ice exists in craters near Mercury's poles, hidden in permanent shadows where sunlight never reaches. These deposits, discovered by spacecraft and confirmed by radar observations, represent some of the most pristine water in the inner solar system, older than complex life on Earth, preserved in perpetual darkness just 36 million miles from our blazing star. Mercury has the most eccentric orbit of any planet, varying from 29 million miles to 43 million miles from the Sun. This elliptical path means that sometimes Mercury races much closer to the Sun's intense heat, while at other times it retreats to a more comfortable distance. The gravitational effects of this eccentric orbit helped Einstein confirm his theory of general relativity, as Mercury's orbit precesses slightly more than Newton's laws predicted. The surface of Mercury bears the scars of billions of years of cosmic bombardment. The Caloris Basin, Mercury's largest impact crater, stretches 960 miles across and was created by an asteroid collision so powerful it sent shockwaves around the entire planet. These ancient impacts created the heavily cratered landscape we see today, a museum of the early solar system's violent formation period, now frozen in time on this small, airless world. Mercury has an extremely thin atmosphere called an exosphere, composed mainly of oxygen, sodium, hydrogen, and helium. This wispy envelope is so thin that it's essentially a vacuum, offering no weather, no winds, and no protection from cosmic radiation or meteorite impacts. The atoms in Mercury's exosphere are constantly being stripped away by the solar wind and replaced by particles knocked off the planet's surface by micrometeorite impacts. Even now, as you rest peacefully, Mercury continues its lonely vigil as the Sun's closest companion. The planet experiences intense tidal forces from the Sun's gravity, which have gradually slowed its rotation and locked it into its current 3:2 spin-orbit resonance. This cosmic dance means that Mercury rotates exactly 3 times for every 2 orbits around the Sun, a celestial rhythm that has persisted for billions of years. From Earth, Mercury appears as a bright star near the horizon just after sunset or before sunrise, never straying far from the Sun in our sky. Ancient astronomers called it both Hermes and Apollo, thinking they were seeing 2 different objects, one that appeared in the evening sky and another in the morning sky. Modern spacecraft have revealed Mercury to be a world of extreme contrasts, with towering cliffs called scarps that stretch for hundreds of miles across its surface. These features formed as the planet's iron core cooled and contracted, wrinkling the surface like the skin of a drying apple, creating a landscape both alien and strangely beautiful in the harsh light of our nearby star. Chapter 3. Venus, the Evening Star. Venus shines as the brightest object in our night sky after the Moon, earning it the poetic names Morning Star and Evening Star throughout human history. This brilliant beacon has guided travelers and inspired lovers for millennia, appearing as a jewel of pure white light that seems to hover just above the horizon at dawn or dusk. As you gaze toward sleep, Venus continues its eternal dance, spending 263 days as the evening star and 263 days as the morning star in an endless, graceful cycle. Beneath its serene appearance lies a world of extraordinary contrasts. Venus rotates backward compared to most planets, spinning from east to west in what scientists call retrograde rotation. If you could stand on Venus's surface and watch the sun rise, it would appear in the west and set in the east. This backward spin may result from a massive collision early in the planet's history, or from the complex gravitational interactions with the sun that gradually reversed its rotation over billions of years. A day on Venus lasts 243 Earth days, making it longer than a Venusian year of 225 Earth days. This means that on Venus, a day is longer than a year, a cosmic curiosity that makes our sister planet unique. In the solar system, The planet rotates so slowly that its day-night cycle creates minimal temperature differences across its surface, unlike the extreme variations found on faster-rotating Mercury. The atmosphere of Venus holds secrets that continue to mystify scientists. Venus's atmosphere is 96% carbon dioxide with crushing surface pressures 90 times greater than Earth's. Standing on Venus would feel like being 3,000 feet underwater on Earth, with an atmosphere so dense that it would support your weight even if you had wings. The atmospheric pressure is so intense that it has crushed every spacecraft that has attempted to land on the surface, allowing them only brief hours of operation before succumbing to the hostile environment. Surface temperatures on Venus reach 900 degrees Fahrenheit, hot enough to melt copper and lead. This extreme heat results from a runaway greenhouse effect, where thick clouds of carbon dioxide and sulfuric acid trap the sun's energy like a cosmic blanket. Interestingly, Venus receives less solar energy than Earth due to its reflective cloud cover, but its atmosphere traps heat so efficiently that it becomes the hottest planet in our solar system, even hotter than Mercury despite being twice as far from the Sun. Long ago, Venus may have been much more Earth-like than it appears today. Scientists theorize that Venus once had liquid water oceans that existed for perhaps 2 billion years. Climate models suggest that if Venus rotated faster, generating a stronger magnetic field, it might have retained its water and remained habitable. Instead, solar radiation gradually stripped away Venus's hydrogen, leaving behind the dense, dry atmosphere we observe today. The clouds of Venus float 30 to 40 miles above the surface in layers of concentrated sulfuric acid. These clouds are so reflective that they bounce about 75% of the sun's light back into space. From space, Venus appears as a brilliant white orb, completely shrouded in its mysterious atmosphere. The cloud tops maintain a relatively comfortable temperature of about 0 degrees Fahrenheit, leading some scientists to speculate about the possibility of floating research stations in Venus's upper atmosphere. Venus shows phases like the Moon when viewed through a telescope, cycling from a thin crescent to a full disk over several months. Galileo's observations of these phases in 1610 provided crucial evidence for the heliocentric model of the solar system, proving that Venus orbits the Sun rather than Earth. These elegant phase changes continue today, visible to anyone with a small telescope, as Venus waxes and wanes in its eternal dance around our central star. Radar mapping has revealed that Venus has a relatively young surface, geologically speaking. About 80% of Venus's surface consists of smooth volcanic plains, suggesting that massive volcanic activity resurfaced the entire planet between 300 and 500 million years ago. This global volcanic renewal erased most impact craters, leaving behind a world dominated by volcanic features including shield volcanoes, lava channels, and vast plains of hardened basalt. Venus has no moons, making it one of only 2 planets in our solar system without natural satellites. This lonely state may result from Venus's proximity to the Sun, where tidal forces make it difficult for small objects to maintain stable orbits. Some theories suggest that Venus once had a moon that was either pulled into the planet or stripped away by solar gravity, leaving our sister world to journey alone through the cosmic night. Even now, as you drift toward dreams, Venus continues its slow, backward rotation under its blanket of acid clouds. Recent discoveries suggest that Venus may still be volcanically active, with evidence of fresh lava flows and changing atmospheric chemistry. Our nearest planetary neighbor remains a world of mysteries, reminding us that even in our own cosmic backyard, there are still wonders waiting to be understood, secrets whispered in the sulfuric winds of our sister world. Chapter 4: Earth, Our Blue Sanctuary. Earth is the only known planet where liquid water exists stably on the surface, creating the blue marble appearance that has captivated astronauts and dreamers alike. From space, our world appears as a delicate sphere of swirling white clouds, deep blue oceans, and patches of green and brown. Continents, a rare oasis of life floating in the infinite darkness of space. As you rest here tonight, you are part of this extraordinary world, spinning gently through the cosmos at 1,000 miles per hour, while orbiting the Sun at 67,000 miles per hour. Our planet's protective magnetic field extends far beyond the atmosphere, creating an invisible shield called the magnetosphere. Earth's magnetic field deflects most of the harmful solar wind and cosmic radiation that would otherwise strip away our atmosphere and make life impossible. This magnetic cocoon extends about 37,000 miles toward the Sun and stretches into a long tail extending millions of miles away from the Sun. Without this protective embrace, Earth would likely resemble Mars, a cold, dry world with only a thin atmosphere. The Moon, our faithful companion, is gradually moving away from Earth at a rate of about 1.5 inches per year. This slow separation means that in the distant past, the Moon appeared much larger in our sky and created more dramatic tides. Billions of years from now, the Moon will appear smaller than the Sun, making total solar eclipses impossible. For now, we live in a unique cosmic moment when the Moon and Sun appear almost exactly the same size in our sky, creating the breathtaking beauty of perfect solar eclipses. Deep beneath your feet, Earth's core spins in a complex dance that generates our magnetic field. The outer core, composed of liquid iron and nickel, rotates at a slightly different speed than the rest of the planet, creating the electric currents that produce our magnetic field. This process, called the geodynamo, has operated for over 3.5 billion years, protecting the development and evolution of life on our planet's surface. Earth's atmosphere is composed of 78% nitrogen, 21% oxygen, and just 1% other gases, including the carbon dioxide that plants breathe and the water vapor that forms our clouds. This precise mixture creates the perfect conditions for life as we know it, maintaining temperatures that keep water liquid across most of the planet's surface. The oxygen we breathe was largely produced by ancient cyanobacteria over billions of years, gradually transforming Earth's atmosphere into the life-supporting envelope we depend on today. The water cycle that brings rain to your garden and fills the rivers and lakes operates on a global scale, powered by the Sun's energy. Approximately 1.3 billion cubic kilometers of water exist on Earth, with 97% in the oceans, 2% locked in ice caps and glaciers, and less than 1% available as fresh water in lakes, rivers, and groundwater. This water has been cycling through Earth systems for billions of years, the same water that dinosaurs drank, that filled ancient seas, and that will continue long after we are gone. Earth experiences seasons because its axis is tilted 23.5 degrees relative to its orbital plane around the Sun. This gentle tilt means that different parts of our planet receive varying amounts of sunlight throughout the year, creating the beautiful cycle of spring flowers, summer warmth, autumn colors, and winter's peaceful rest. Without this tilt, Earth would have no seasons, and the climate would be more uniform but far less dynamic and interesting. Plate tectonics keeps our planet geologically active, with continents slowly drifting across the surface over millions of years. The continents move at about the same rate your fingernails grow, roughly 2 inches per year. This slow dance of the continents has shaped Earth's surface for billions of years, creating mountain ranges, ocean basins, and the diverse landscapes that make our world so beautiful. The Himalayas are still growing as the Indian plate pushes into the Eurasian plate, while the Atlantic Ocean widens as the Americas drift away from Europe and Africa. Earth's gravity varies slightly across the planet's surface due to differences in elevation, rock density, and the planet's rotation. You actually weigh slightly less at the equator than at the poles, both because you're farther from Earth's center due to the planet's rotation and because the centrifugal force of rotation provides a tiny upward push. These variations are so small you'd never notice them, but they're precisely measured by scientists studying Earth's internal structure. Life on Earth exists in a thin layer called the biosphere, extending from the deepest ocean trenches to the highest reaches of the atmosphere. This biosphere is only about 12 miles thick, thinner than the skin of an apple relative to Earth's 8,000-mile diameter. Within this narrow band, life has flourished for nearly 4 billion years, evolving from simple bacteria to the incredible diversity of plants, animals, and microorganisms that share our planet today. Every day, about 100 tons of cosmic dust and small meteoroids enter Earth's atmosphere, most burning up as shooting stars before reaching the ground. These tiny visitors from space add mass to our planet and remind us that Earth is not isolated in space but constantly interacting with the cosmic environment around us. As you sleep tonight, microscopic particles that began their journey in distant asteroid belts or comet tails are gently settling onto Earth's surface, carrying with them the story of our solar system's formation billions of years ago. Chapter 5. Mars, the Rusty Horizon. Mars appears red in our night sky due to iron oxide, essentially rust, covering much of its surface, earning it the nickname, the Red Planet. This rusty dust gives Mars its distinctive salmon pink appearance, created over billions of years as iron-rich rocks were slowly oxidized by trace amounts of oxygen and water in the Martian atmosphere. As you rest peacefully tonight, Mars continues its stately orbit, taking 687 Earth days to complete one journey around the Sun, experiencing seasons twice as long as ours. Long ago, Mars was a much warmer and wetter world than the cold desert we see today. Evidence suggests that liquid water flowed freely on Mars's surface between 3 and 4 billion years ago, creating river valleys, lake beds, and possibly even oceans. Ancient riverbeds carved into the Martian landscape tell the story of a time when rain may have fallen from thick clouds and streams meandered across continents under a denser atmosphere. This water didn't simply disappear. Much of it likely escaped to space when Mars lost its magnetic field and atmosphere. Mars has 2 small moons, Phobos and Deimos, whose names mean fear and panic in Greek. These tiny, irregularly shaped moons are probably captured asteroids, with Phobos measuring just 17 miles across and Deimos only 9 miles. Phobos orbits so close to Mars that it completes 3 orbits in a single Martian day, appearing to race across the sky from west to east. Deimos, the smaller and more distant moon, takes 30 hours to orbit Mars, rising in the east and setting in the west like our own moon. The largest volcano in the solar system rises majestically from Mars's surface. Olympus Mons stands 13.6 miles high, nearly 3 times taller than Mount Everest, and spreads 374 miles across its base. This enormous shield volcano formed over millions of years as layer upon layer of lava slowly built up, creating a mountain so large it would cover the entire state of Arizona. Its gentle slopes rise so gradually that if you stood on Mars and climbed Olympus Mons, you might not even realize you were ascending a mountain until you looked back at the vast plain below. A day on Mars lasts 24 hours and 37 minutes, remarkably similar to Earth's day. This familiar rhythm would make Mars feel somewhat like home to human visitors, with sunrise and sunset occurring at intervals close to our natural circadian rhythms. However, a year on Mars contains 669 Martian days, making each season about twice as long as Earth's seasons, with spring and summer being particularly long in Mars's southern hemisphere. The atmosphere of Mars is incredibly thin, with a surface pressure less than 1% of Earth's. Despite this thin atmosphere, Mars experiences weather phenomena including dust storms that can engulf the entire planet for months at a time. These global dust storms occur roughly every few years, turning the Martian sky from its usual butterscotch color to a dark orange-brown and causing temperatures to rise as the dust absorbs sunlight. When the storms finally subside, it takes weeks for the dust to settle back to the surface. Mars has polar ice caps composed of both frozen carbon dioxide, dry ice, and water ice. During the Martian winter, carbon dioxide freezes out of the atmosphere at the poles, causing the ice caps to grow larger. In summer, this dry ice sublimes directly back into gas, shrinking the polar caps and revealing the underlying water ice beneath. The northern polar cap contains enough water ice that if it melted, it could cover the entire planet in about 35 feet of water. The largest canyon system in the solar system stretches across Mars's equatorial region. Valles Marineris extends over 2,500 miles long, 125 miles wide, and up to 4 miles deep, making it 10 times longer, 20 times wider, and 5 times deeper than the Grand Canyon. This vast scar across Mars's face likely formed as the planet's crust cracked and stretched, possibly due to the enormous weight of nearby volcanic regions. If placed on Earth, Valles Marineris would stretch from New York to Los Angeles. Mars experiences the largest dust storms in the solar system, with winds that can reach 60 miles per hour during major storms. However, due to the thin atmosphere, these winds would feel like gentle breezes to a human, carrying far less force than similar wind speeds on Earth. The fine rust-colored dust is so light that it can remain suspended in the atmosphere for months, creating the perpetual twilight, conditions that can shut down solar-powered rovers and spacecraft. Recent discoveries have revealed that Mars still holds significant amounts of water locked away beneath its surface. Radar observations suggest that Mars contains vast underground reservoirs of liquid water, possibly holding more water than the Great Lakes combined. This hidden water exists in aquifers deep beneath the Martian surface, protected from the cold and low pressure that would cause surface water to freeze or boil away. Some of these underground lakes may have existed for millions of years, raising intriguing questions about the possibility of life persisting in Mars's subsurface environment. Martian soil contains perchlorates, chemical compounds that are toxic to humans but might be used as rocket fuel for return trips to Earth. These perchlorates also lower the freezing point of water, potentially allowing liquid brine to exist in Mars's soil even at temperatures well below the normal freezing point of pure water. As you drift towards sleep, Mars continues its patient orbit, a world that once flowed with rivers and may still harbor life in hidden underground refuges, waiting for future explorers to unlock its ancient secrets. Chapter 6: Jupiter, the Great Guardian. Jupiter is so massive that it contains more than twice the mass of all other planets in our solar system combined. This giant world serves as a cosmic guardian for the inner planets, its immense gravity acting like a celestial vacuum cleaner that sweeps up asteroids and comets that might otherwise threaten Earth. As you rest peacefully tonight, Jupiter continues its stately 12-year orbit around the Sun, its great bulk protecting our small blue world from cosmic debris that has wandered too close to the inner solar system. The most famous feature on Jupiter is a storm system larger than Earth itself. The Great Red Spot is a hurricane that has been raging continuously for at least 350 years, and possibly much longer. This massive storm rotates counterclockwise every 6 days, with winds reaching speeds of 250 miles per hour. The storm's distinctive rust-colored appearance comes from complex chemical reactions in Jupiter's atmosphere, where compounds of phosphorus and sulfur interact with ultraviolet light from the sun to create the beautiful reddish hues we observe through telescopes. Jupiter rotates faster than any other planet in our solar system, completing one full rotation in just 9 hours and 55 minutes. This rapid spin causes the giant planet to bulge noticeably at its equator, making it appear flattened when viewed through a telescope. The fast rotation also creates Jupiter's distinctive bands of clouds, as the planet's rapid spin stretches weather systems into long strips that circle the planet in alternating light and dark zones. Beneath Jupiter's colorful cloud tops lies an atmosphere of incredible depth and complexity. Jupiter's atmosphere extends downward for thousands of miles, gradually becoming so compressed that hydrogen transitions from gas to liquid and eventually to a metallic state. Deep in Jupiter's core, hydrogen exists in conditions so extreme that it behaves like a liquid metal, conducting electricity and generating the planet's powerful magnetic field. This magnetic field extends millions of miles into space, creating a magnetosphere so large it could contain the Sun. Jupiter has at least 95 known moons, making it like a miniature solar system unto itself. The four largest moons, Io, Europa, Ganymede, and Callisto, were discovered by Galileo in 1610 and revolutionized our understanding of the cosmos. These Galilean moons are large enough to be considered planets if they orbited the Sun directly, each with its own unique characteristics and mysteries that continue to fascinate scientists today. Io, the innermost of Jupiter's large moons, is the most volcanically active body in the solar system. Io has over 400 active volcanoes that spew sulfur and sulfur dioxide hundreds of miles into space. This constant volcanic activity is powered by tidal heating, as Jupiter's immense gravity stretches and flexes Io's interior, generating friction that melts rock deep within the moon. The volcanic plumes from Io are so dramatic they can be seen from spacecraft millions of miles away, creating colorful fountains of material that paint Io's surface in brilliant yellows, oranges, and reds. Europa, Jupiter's ice-covered moon, likely contains more liquid water than all of Earth's oceans combined. Beneath Europa's smooth, frozen surface lies a global ocean that may be 60 miles deep, kept liquid by tidal heating from Jupiter's gravity. This hidden ocean, protected from space radiation by Europa's ice shell, represents one of the most promising places to search for life beyond Earth. The ocean has likely existed for billions of years, providing a stable environment where life might have evolved in the eternal darkness beneath the ice. Ganymede holds the distinction of being the largest moon in our solar system, even bigger than the planet Mercury. Ganymede is the only moon known to have its own magnetic field, creating beautiful auroras at its poles similar to the northern and southern lights on Earth. Like Europa, Ganymede likely harbors a subsurface ocean beneath its icy crust, making it another potential haven for life in the outer solar system. Jupiter's gravity is so strong that it accelerates spacecraft passing by, allowing mission planners to use gravitational slingshots to send probes to the outer planets. Many deep space missions have used Jupiter as a stepping stone, gaining speed and changing direction by flying close to the giant planet. This gravitational assist technique has enabled spacecraft to reach Saturn, Uranus, Neptune, and beyond with less fuel and shorter travel times than would otherwise be possible. The composition of Jupiter tells the story of our solar system's formation. Jupiter is composed primarily of hydrogen and helium in roughly the same proportions as the Sun, suggesting that Jupiter formed early in the solar system's history when these light elements were still abundant. If Jupiter had been about 75 times more massive, it would have ignited nuclear fusion and become a second star in our system, creating a very different cosmic neighborhood where Earth might never have formed or harbored life. Jupiter emits more heat than it receives from the Sun, radiating about 67% more energy than it absorbs. This excess heat comes from the slow gravitational contraction of the planet, as Jupiter gradually shrinks under its own weight and converts gravitational potential energy into thermal energy. This process has been occurring for billions of years and will continue for billions more, making Jupiter a warm, glowing ember in the cold darkness of the outer solar system. Even now, as you drift peacefully towards sleep, Jupiter's ancient dance continues, its great gravitational influence shepherding asteroids and comets, protecting the inner planets while nurturing its own family of moons. In the vast silence of space, this gentle giant maintains its eternal watch, a cosmic lighthouse, whose presence has helped make life possible on our small, distant world. Chapter 7. Saturn, the Ringed Beauty. Saturn's ring system spans nearly 175,000 miles from edge to edge, yet averages only about 30 feet thick, making them proportionally thinner than a sheet of paper. These magnificent rings, composed primarily of countless chunks of water ice ranging in size from tiny grains to house-sized boulders, create the most spectacular sight in our solar system. As you rest tonight, Saturn continues its graceful 29-year journey around the Sun, its rings tilting and changing their appearance from Earth as our perspective shifts with the seasons. The rings of Saturn are not solid disks but consist of billions of individual particles, each following its own orbit around the planet. These ring particles range in size from microscopic ice crystals to chunks as large as mountains, all dancing in complex gravitational harmony. The rings are held in place by the gravitational influence of Saturn's many moons, some of which act as shepherds, using their gravity to keep ring particles confined to narrow bands. Other small moons, called moonlets, actually orbit within the rings themselves, creating gaps and waves in the icy material. Saturn is the least dense planet in our solar system, so light that it would actually float if you could find an ocean large enough to hold it. This low density occurs because Saturn is composed primarily of hydrogen and helium gas, with very little rocky or metallic material. The planet's rapid 10.7-hour rotation day causes it to bulge significantly at the equator, giving Saturn a noticeably flattened appearance that's visible even through small telescopes. Deep within Saturn's atmosphere lies one of the most perfectly geometric features in the natural world. Hexagonal storm system caps Saturn's North Pole, with each side of the hexagon stretching about 8,600 miles, wide enough that 2 Earths could fit inside it. This mysterious six-sided pattern has persisted for decades, possibly much longer, creating a geometric puzzle that scientists are still working to understand. The hexagon rotates with the same period as Saturn's interior, suggesting it's deeply connected to the planet's internal structure. Titan, Saturn's largest moon, is larger than the planet Mercury and possesses a thick atmosphere that makes it unique among moons in our solar system. Titan's atmosphere is primarily nitrogen, much like Earth's, but also contains methane that creates clouds and rain, forming lakes and rivers of liquid methane and ethane on the surface. This distant moon experiences seasons similar to Earth's, but each season lasts about 7 Earth years due to Saturn's long orbital period around the Sun. The methane cycle on Titan mirrors the water cycle on Earth, with methane evaporating from lakes, forming clouds, and falling as rain to carve river channels and fill vast seas. These hydrocarbon seas, with poetic names like Kraken Mare and Ligeia Mare, represent some of the most Earth-like landscapes in the outer solar system, despite being composed of liquid methane at temperatures of -290 degrees Fahrenheit. Enceladus, another of Saturn's moons, harbors one of the solar system's most spectacular features. Geysers of water ice and vapor shoot over 500 miles high from cracks near Enceladus's south pole, creating a constant spray of material that feeds one of Saturn's rings. These geysers indicate that a liquid water ocean exists beneath Enceladus's icy crust, kept warm by tidal heating from Saturn's gravity. This hidden ocean may contain twice as much water as all of Earth's oceans combined. Saturn has at least 146 known moons, ranging from tiny irregular chunks of rock and ice to the planet-sized Titan. Many of these moons have orbital relationships that create gravitational resonances, where their orbital periods are related by simple mathematical ratios. These resonances help stabilize the orbits and prevent the moons from colliding with each other, creating a delicate cosmic dance that has persisted for billions of years. The Cassini spacecraft, which studied Saturn for 13 years until 2017, revealed that Saturn's rings are much younger than previously thought. Evidence suggests that Saturn's rings may be only 100 to 200 million years old, meaning they formed when dinosaurs walked on Earth. This relatively recent origin might result from the breakup of a large moon that wandered too close to Saturn and was torn apart by tidal forces, spreading its remains in the beautiful ring system we observe today. Saturn's magnetic field is nearly perfectly aligned with its rotation axis, making it unique among planets with strong magnetic fields. This unusual alignment means that Saturn lacks the complex aurora displays seen on other planets like Jupiter and Earth, where tilted magnetic fields interact with charged particles from space. Instead, Saturn's auroras are more uniform and less dramatic, creating gentle curtains of light at the planet's poles. The seasonal changes on Saturn create dramatic transformations in the planet's appearance. As Saturn's 29-year orbit carries it around the Sun, different portions of the rings are illuminated, sometimes showing the rings edge-on from Earth's perspective, making them nearly invisible. During these edge-on periods, which occur every 14 to 15 years, astronomers can study the ring's thickness and discover new features that are usually hidden by the ring's brightness. Even now, as you settle into peaceful sleep, Saturn continues its eternal waltz through the outer solar system, its rings catching and reflecting sunlight in an endless display of cosmic beauty. The shepherd moons continue their patient work, maintaining the gaps and divisions in the rings, while Titan's methane rains fall silently in the frigid darkness, and Enceladus's geysers spray their icy fountains into the vacuum of space, reminding us that even in the cold, distant reaches of our solar system, dynamic and beautiful processes continue their ancient rhythms. Chapter 8. The Distant Ice Giants. Uranus rolls on its side as it orbits the Sun, with its axis tilted 98 degrees from vertical, essentially spinning like a ball rolling along a table. This extreme tilt means that Uranus experiences the most unusual seasons in the solar system, with each pole experiencing 42 years of continuous sunlight, followed by 42 years of complete darkness. As you rest peacefully tonight, somewhere on Uranus, regions that have been shrouded in winter darkness for decades are finally beginning to see their first sunrise in a human generation. This ice giant appears as a serene blue-green orb when viewed from Earth, colored by methane in its atmosphere that absorbs red light and reflects blue wavelengths back to space. Uranus is so distant from the Sun that it receives only 1/400th the sunlight that Earth receives, making it a cold, quiet world, where noon feels like perpetual twilight. Despite this distance, Uranus maintains an atmosphere of hydrogen, helium, and methane that creates gentle cloud formations and produces winds of up to 350 miles per hour. The discovery of Uranus in 1781 by William Herschel doubled the known size of our solar system overnight. Until that moment, humans believed the solar system ended at Saturn, making Uranus the first planet discovered in modern times and the first to be found using a telescope. This distant world takes 84 Earth years to complete one orbit around the Sun, meaning it has completed only about 3 orbits since its discovery. Uranus possesses a faint ring system, discovered in 1977, consisting of narrow, dark rings that are quite different from Saturn's bright, icy rings. The rings of Uranus are composed of dark particles, possibly organic compounds that have been altered by radiation over millions of years. These rings are so narrow and dark that they remained hidden until astronomers observed them blocking starlight during a rare stellar occultation, revealing Uranus as the second planet known to have rings. Uranus has 27 known moons, all named after characters from the works of William Shakespeare and Alexander Pope. The largest moons, Titania, Oberon, Umbriel, Ariel, and Miranda, display a fascinating variety of geological features. Miranda, the smallest of the major moons, shows evidence of extreme geological activity in its past, with towering cliffs, deep canyons, and a patchwork surface that suggests it may have been shattered and reassembled by cosmic collisions. Neptune, the outermost of the traditional planets, shines with the deepest blue color in the solar system. This azure jewel owes its striking appearance to methane in its atmosphere, but the exact mechanism that creates Neptune's more intense blue color compared to Uranus remains a mystery. Neptune receives even less sunlight than Uranus, only 1/900th of Earth's solar energy, yet it radiates 2.6 times more heat than it receives from the Sun, indicating a powerful internal energy source that drives the most dynamic weather in the outer solar system. Neptune experiences the fastest winds in the solar system, with storms racing around the planet at speeds up to 1,200 miles per hour. These supersonic winds are particularly puzzling because they occur on a world that receives so little energy from the Sun. The most famous storm system, called the Great Dark Spot, was a hurricane-like feature larger than Earth that was observed by the Voyager 2 spacecraft in 1989, though it had disappeared by the time the Hubble Space Telescope looked for it in 1994. A year on Neptune lasts 165 Earth years, meaning that since its discovery in 1846, Neptune has completed only one full orbit around the Sun. This milestone was reached on July 12, 2011, marking Neptune's first birthday since human eyes first gazed upon it. The planet's discovery itself represents a triumph of mathematical astronomy, as Neptune was found not by chance observation but through calculations predicting where an undiscovered planet should be located based on its gravitational effects. On Uranus's orbit, Triton, Neptune's largest moon, is one of the most intriguing objects in the outer solar system. Triton orbits Neptune backward, in the opposite direction from the planet's rotation, and is likely a captured Kuiper belt object, possibly similar to Pluto. Despite being one of the coldest places in the solar system, with surface temperatures of -391 degrees Fahrenheit, Triton shows signs of geological activity, including nitrogen geysers that shoot dark material several miles into its thin atmosphere. Both Uranus and Neptune are classified as ice giants rather than gas giants because they contain much more water, methane, and ammonia ice in their composition. Their interiors likely consist of small, rocky cores surrounded by mantles of water, methane, and ammonia ices, all compressed into exotic states of matter that don't exist naturally on Earth. The extreme pressures and temperatures in their interiors may create conditions where carbon is compressed into diamonds, leading to the intriguing possibility of diamond rain falling through the deep atmospheres of these distant worlds. The magnetospheres of both ice giants are tilted at unusual angles relative to their rotation axes and are offset from the planet centers. Uranus's magnetic field is tilted 59 degrees from its rotation axis, while Neptune's is tilted 47 degrees. These unusual magnetic field configurations suggest that the magnetic fields are generated not in the planet's cores but in their ice-rich mantles, where electrically conductive fluids create complex current systems. Even now, as you drift toward sleep, these distant ice giants continue their patient journeys through the outer darkness of our solar system. Uranus rolls along its orbital path like a cosmic wheel, while Neptune's azure atmosphere churns with the fastest winds in the solar system, both worlds maintaining their ancient rhythms in the cold silence beyond the orbit of Saturn. Their moons circle in complex dances, some forward, some backward, all participating in the grand celestial choreography that has continued unchanged since the solar system's youth, billions of years before the first human eyes turned skyward to wonder at the lights moving among the stars. Chapter 9. Asteroid Belts and Cosmic Wanderers. Between the orbits of Mars and Jupiter lies a vast region populated by hundreds of thousands of rocky fragments, ranging from pebbles to objects hundreds of miles across. This asteroid belt, contrary to science fiction portrayals, is actually quite sparse, you could fly a spacecraft through it with little chance of collision. The asteroids are spread across such an enormous volume of space that the average distance between them is about 600,000 miles, roughly twice the distance from Earth to the Moon. The largest resident of the asteroid belt is Ceres, now classified as a dwarf planet. Ceres contains about 1/3 of the asteroid belt's total mass and is large enough that its own gravity has pulled it into a roughly spherical shape. This miniature world, about 584 miles in diameter, harbors surprising secrets. Beneath its dusty surface, recent spacecraft observations have revealed that Ceres likely contains more fresh water than Earth, locked away in subsurface oceans and ice deposits that may have existed for billions of years. Most asteroids are remnants from the early solar system, leftover building blocks that never accumulated into a planet due to Jupiter's gravitational influence. These cosmic fossils preserve the original materials from which the rocky planets formed, making them valuable windows into our solar system's youth. Some asteroids are primitive and largely unchanged since their formation 4.6 billion years ago, while others have been heated, melted, and differentiated into metal cores and rocky mantles, just like miniature planets. The asteroid Vesta, the second most massive object in the belt, tells a remarkable story of cosmic violence and survival. Vesta experienced massive collisions that blasted enormous chunks of material into space, some of which eventually fell to Earth as meteorites. Scientists have identified over 1,000 meteorites on Earth that originated from Vesta, making it the only asteroid from which we have laboratory samples. These Vesta meteorites reveal that this small world underwent the same geological processes as the rocky planets, developing a metal core, rocky mantle, and thin crust. Trojan asteroids share the same orbital path as Jupiter, traveling in two groups that lead and follow the giant planet by 60 degrees. These cosmic companions, trapped in gravitationally stable points called Lagrange points, number in the thousands and may include some of the solar system's most primitive objects. The Jupiter Trojans are named after heroes of the Trojan War, with the leading group honoring Greek heroes and the trailing group honoring Trojans, creating a cosmic reenactment of Homer's epic tale. Some asteroids follow paths that bring them close to Earth, earning them the designation of near-Earth objects, NEOs. More than 34,000 near-Earth asteroids have been discovered, ranging from tiny rocks just a few feet across to giants over a mile in diameter. Most of these cosmic wanderers pose no threat to our planet, but astronomers carefully track their orbits to identify any that might someday come dangerously close to Earth. The vast majority will continue their harmless orbits for millions of years, occasionally providing spectacular meteor showers when Earth passes through debris trails they leave behind. The composition of asteroids varies dramatically, telling different stories of formation and evolution. C-type asteroids are dark and carbon-rich, containing organic compounds and water-bearing minerals that may have helped seed early Earth with the ingredients for life. S-type asteroids are brighter and rocky, composed mainly of silicate minerals and metals. M-type asteroids are metallic, likely the exposed cores of larger bodies that were shattered by ancient collisions, leaving behind chunks of nearly pure iron and nickel floating in space. The asteroid belt experiences its own gentle seasons as it orbits the Sun. Asteroids closer to the Sun complete their orbits faster than those farther out, creating a slow cosmic dance where faster inner asteroids occasionally overtake their outer neighbors. This differential motion, combined with gravitational perturbations from the planets, occasionally sends asteroids on new trajectories, sometimes ejecting them from the belt entirely to become planet-crossing objects or even comets. Binary asteroids, pairs of rocks orbiting around each other, are surprisingly common in the asteroid belt. These cosmic couples formed when larger asteroids were gently disrupted by collisions or tidal forces, creating systems where two objects dance around their common center of mass. Some binary Asteroids are nearly equal in size, while others consist of a large primary with a much smaller moon. The study of these systems helps scientists understand how asteroids evolve and interact over billions of years. Recent missions to asteroids have revealed that many of these small worlds are not solid rocks but rather rubble piles, loose collections of boulders held together by weak gravity. The asteroid Bennu, visited by NASA's OSIRIS-RX mission, has such low gravity that a baseball thrown from its surface would escape into space. These fragile assemblages formed when larger asteroids were shattered by collisions, with the fragments slowly reaggregating into loose, porous structures that are more like flying gravel piles than solid rocks. Every day, about 5 to 10 tons of asteroid material enters Earth's atmosphere as meteors, most of it burning up harmlessly as shooting stars. This constant rain of cosmic dust and small rocks connects us directly to the asteroid belt, bringing samples of these ancient worlds to our doorstep. Occasionally, larger fragments survive their fiery passage through the atmosphere to land as meteorites, providing scientists with pristine samples of solar system history that can be studied in terrestrial laboratories. Even now, as you rest peacefully, the asteroids continue their ancient orbits, slowly tumbling through space in the gentle gravitational embrace of the Sun. Some spin rapidly, completing rotations in just a few hours, while others turn so slowly that their days last weeks. In the cold vacuum between Mars and Jupiter, these remnants of planetary formation maintain their patient vigil, preserving the story of our solar system's birth in their rocky hearts, waiting for future explorers to unlock the secrets they have carried through billions of years of cosmic history. Chapter 10: Comets and the Outer Reaches. Comets are ancient time capsules from the outer edges of our solar system, preserving materials that have remained virtually unchanged for over 4.6 billion years. These dirty snowballs, composed of water ice, frozen gases, and rocky particles, spend most of their existence in the cold darkness beyond the planets, occasionally making spectacular journeys toward the Sun that transform them into some of the most beautiful objects in our sky. As you settle into peaceful rest tonight, countless comets drift silently through the outer reaches of our solar system, waiting for gravitational nudges that will send them on their next visit to the inner solar system. The most famous comet, Halley's Comet, follows a predictable 76-year orbit that has been recorded by human civilizations for over 2,000 years. Halley's Comet last appeared in 1986 and will return in 2061, giving it the distinction of being the only comet visible to the naked eye that returns within a human lifetime. Ancient Chinese astronomers recorded its appearances as early as 240 BC, and the comet has been interpreted as everything from a harbinger of doom to a celestial celebration, appearing in the Bayeux Tapestry depicting the Norman conquest of 1066. Most comets originate from two vast reservoirs at the edge of our solar system, the Kuiper Belt and the Oort cloud. The Kuiper Belt, extending from Neptune's orbit to about 50 times Earth's distance from the Sun, contains thousands of icy objects including dwarf planets like Pluto, Eris, and Makemake. Short-period comets, which orbit the Sun in less than 200 years, typically originate from this region and have been nudged into the inner solar system by gravitational interactions with the giant planets. The Oort cloud, a spherical shell of icy objects surrounding our entire solar system, extends from about 2,000 to 100,000 times Earth's distance from the Sun. This vast reservoir may contain trillions of comets, though it's so distant that its outer edge is nearly a quarter of the way to the nearest star. Long-period comets, which take hundreds or thousands of years to complete their orbits, originate from the Oort cloud and can approach the Sun from any direction, creating spectacular but unpredictable appearances in our sky. When a comet approaches the inner solar system, the Sun's heat begins to vaporize its icy surface, creating the characteristic tail that makes comets so spectacular. Comets actually develop two distinct tails, a blue gas tail that points directly away from the Sun, and a yellowish dust tail that curves along. The comet's orbital path. The gas tail, composed of ionized molecules, can extend over 100 million miles from the comet's nucleus, while the dust tail contains tiny particles that eventually spread throughout the solar system, sometimes creating meteor showers when Earth passes through these debris trails. The nucleus of a typical comet is surprisingly small, usually just a few miles across, but can produce tails that stretch across hundreds of millions of miles of space. This dramatic transformation occurs because comet material is incredibly fluffy and porous, with a density less than water. When solar heating vaporizes the surface, tremendous volumes of gas and dust are released, creating the spectacular displays we observe from Earth, while the tiny nucleus remains hidden within the bright coma of vaporized material. Pluto, once classified as the 9th planet, is now recognized as the largest known member of the Kuiper Belt family. Pluto and its largest moon, Charon, are so similar in size that they form a binary system, orbiting around a point in space between them rather than Charon simply orbiting Pluto. This distant pair takes 248 Earth years to orbit the Sun, meaning that Pluto hasn't completed a full orbit since its discovery in 1930. The New Horizons spacecraft's 2015 flyby revealed Pluto to be a geologically active world with nitrogen glaciers, methane dunes, and a thin atmosphere that changes dramatically as Pluto moves closer to and farther from the Sun. Other dwarf planets in the outer solar system include Eris, which is slightly smaller than Pluto but more massive, and Makemake, which shows signs of having a thin atmosphere despite its great distance from the Sun. These distant worlds, along with hundreds of smaller Kuiper Belt objects, represent a third zone of our solar system, neither the rocky inner planets nor the gas giants, but a realm of ice and rock that preserves the original conditions from the solar system's formation. Comets have played crucial roles in Earth's history, possibly delivering much of the water that fills our oceans and the organic compounds that helped spark life. Some scientists theorize that a period called the Late Heavy Bombardment, about 4 billion years ago, brought comets and asteroids crashing into the inner solar system, delivering water and carbon-based molecules to the young Earth. This cosmic delivery service may have provided the raw materials necessary for life to emerge on our planet, making comets not just beautiful celestial visitors but potentially the seeds of terrestrial life. The Kuiper Belt and Oort cloud mark the transition from our solar system to interstellar space, where the Sun's gravitational influence begins to fade and the gravity of nearby stars becomes significant. In this distant realm, temperatures hover just a few degrees above absolute zero, and objects move so slowly that orbital periods can span millions of years. Yet even here, in the cold darkness at the edge of known space, complex processes continue. Objects collide and fragment, gravitational perturbations slowly alter orbits, and the solar wind carries the Sun's influence far beyond the orbits of the planets. Recent discoveries have revealed that some objects in the outer solar system have highly elliptical orbits that may indicate the presence of an undiscovered 9th planet. This hypothetical planet 9, if it exists, would be roughly the size of Neptune but orbit the Sun at a distance 20 times farther than Neptune, taking 10,000 to 20,000 years to complete one orbit. The search for this elusive world continues as astronomers study the gravitational effects it might have on the orbits of distant Kuiper Belt objects. Interstellar comets, visitors from other star systems, occasionally pass through our solar system, providing glimpses of planetary formation processes around distant stars. The first confirmed interstellar visitor, Oumuamua, was discovered in 2017 and showed unusual properties that suggested it might be more like a comet than an asteroid, despite lacking the typical comet tail. More recently, Comet Borisov provided a clearer example of an interstellar comet, allowing astronomers to study material formed around another star billions of years ago. Even now, as you drift peacefully toward sleep, the outer reaches of our solar system continue their ancient, slow dance. Comets follow their patient orbits through the cold darkness, occasionally beginning the long journey toward the sun that will transform them into brilliant celestial messengers. In the Kuiper Belt, Pluto and Charon continue their synchronized waltz, while in the vast Oort cloud, trillions of icy worlds wait in the perpetual night, preserving the pristine materials from which our solar system formed, ready to tell their stories to future generations of explorers who will venture into these distant realms to unlock the final secrets of our cosmic home. Closing section. As our gentle journey through the solar system draws to a close, take a moment to marvel at the extraordinary neighborhood in which we live. From the blazing nuclear furnace of our sun to the icy wanderers in the distant Oort cloud, we have traveled across billions of miles of space and billions of years of time, discovering worlds of wonder that exist right here in our cosmic backyard. Tonight, as you rest peacefully on our beautiful blue planet, remember that you are part of this magnificent cosmic dance. The calcium in your bones was forged in the heart of an ancient star, the iron in your blood was created in stellar furnaces, and the water in your body may have traveled here on comets from the outer reaches of space. You are literally made of stardust, a temporary assembly of cosmic materials that have journeyed across the universe to come together as you, conscious and aware, capable of contemplating the very cosmos from which you came. Every breath you take connects you to this larger story. The oxygen you breathe was produced by ancient bacteria and countless generations of plants, all powered by the same sun that warms Mercury's day side and creates the seasons on distant Uranus. The ground beneath you is part of a planet that has been shaped by impacts from asteroids, warmed by radioactive decay from elements created in dying stars, and protected by a magnetic field generated in our planet's molten core. As you settle into sleep, let your mind drift across the solar system one more time. Picture Jupiter standing guard, its immense gravity protecting us from cosmic debris. Visualize Saturn's rings catching starlight in their icy particles, while Titan's methane rains fall in the frigid darkness. Imagine the ancient impact craters on Mercury, each one a story of cosmic collision written in stone, and the vast canyons of Mars, carved by rivers that flowed when our planet was young and life was just beginning to stir in Earth's primordial oceans. Remember too that this solar system is just one among hundreds of billions of others in our galaxy alone. The same physical laws that govern the orbits of our planets and the fusion processes in our sun operate throughout the universe, creating countless other worlds, other sunrises, other possibilities for the cosmos to know itself through conscious beings like yourself. Science continues to reveal new wonders in our solar system with each passing year. Future explorers will walk on Mars, dive beneath the ice of Europa, float through the upper atmospheres of Venus and Titan, and perhaps even venture to the Kuiper Belt to study comets in their pristine, frozen state. Each mission, each discovery, adds new chapters to the story we have shared tonight, expanding our understanding of the cosmic home we inhabit. But for now, let the peace of the cosmos settle over you like a gentle blanket. The same gravitational forces that keep the planets in their orbits hold you safely to the surface of this world. The same nuclear processes that power the sun will continue to provide warmth and light for billions of years to come. In the vast silence of space, our solar system continues its ancient rhythms, a clockwork of worlds that has kept perfect time for over 4.5 billion years. Thank you for joining me on this peaceful journey through our solar system. If you enjoyed this voyage among the planets, you might also enjoy our other explorations of cosmic wonders, perhaps a gentle tour through the life cycles of stars, or a quiet journey through the seasons here on Earth. Until then, may your dreams be filled with the beauty and wonder of the cosmos, and may you rest peacefully knowing that you are part of something infinitely larger and more beautiful than can ever be fully comprehended. Sweet dreams, fellow traveler among the stars. The universe is vast, ancient, and magnificent, and you belong to it as surely as it belongs to you.